So, if you remember yesterday, we had a discussion till till non-return damper, right? We need to continue the other components. So we will start with there's a kind of a repeated voice through my kind of reason. Is my voice clear? Hello.
Yes, sir.
Okay. So then we have something called as a VAV, variable air volume damper. So variable air volume damper is hardware which is used to control the air according to the room temperature. So we learn about more about this VAV later. Don't worry, you have multiple types of VAVs like bypass VAV, a normal VAV that we use it. For which actuators. But all these things we'll have a discussion later. So don't worry about this VAV as of now. I mean, for you to understand it briefly, basically it's a hardware that is used to control the airflow according to the temperature of that particular room space. That means you can control the particular zone's temperature using this variable air volume damper. Yeah, but whenever you have a VAV, unless it's a bypass VAV, it's a normal VAV, it's mandatory for you to have a VFD. Those all concepts we'll have a discussion later. Is it fine? So then coming to the next hardware the next important thing that we have is something called as attenuator. So attenuator is a hardware that is used to reduce the noise inside the room space. So these attenuators, we use it for near AHU rooms and all, we go for the sound attenuator. Whereas in independent rooms, we go for this crosstalk dampers whenever we have these meeting rooms or anything. Understand? Especially if we have a centralized air conditioning system. So I'll just show you this particular one. Steady, I didn't save it, is it? Because I didn't save yesterday's file, but that's okay. No, I didn't save this file. That's okay. So whenever you've got a room space, let's say you have a very big office spaces, and you might have multiple rooms, right? Multiple cabins. You agree?
Yeah.
You can have multiple rooms, like heated chemicals. You can have multiple rooms across. So in this case, let's say I've gone for a floor-mounted AHU. Let's say I've got a AHU room at this location. And so from this room, basically, I've gone for ducting system. Ducting reason I'll be teaching you, don't worry. Okay. So let's say I've done a ducting system like this. I've got a plenum inside it's a floor mounted AHU. So from here, let's say one duct have come like this, one duct have come like this, and one more duct have gone like this, and then we have supplied air to every cabin. You agree I can do something like this? A distribution or not? And retainer, obviously, I'll keep the openings so that the air will be coming above fall ceiling to this particular AHU. So when you have this kind of arrangements, then what can happen is inside the return air, whatever, see, because obviously to this AHI should even have return air, right? So what do we do in general cases? I mean, let's say this is the elevation. I'm drawing it. Okay. This is your false ceiling, and in AHU room, you don't have any false ceiling anyway. So your AHU room will be full height. So what do we do is basically if supply is like this, if this is your supply duct, let's say, to your room space, return will be through returner diffusers, punctures in the ceiling. That's the second. So this is your supply. So basically what will happen, this is, say, let's say people are over here. So from here, the hot air will reach back to this one. Obviously, you'll provide an opening here. You agree? You'll provide an opening over here. So in this case, what is going to happen? Whatever the noise that is there over here, see in one cabin, don't you think through written air it can reach to others? That means if someone is outside over here through written air, like don't you think the voice will be slightly heard at this location or not?
Yes, sir.
So for that reason, wherever we have written air opening, we will provide this crosstalk dampers. So your dampers will be something like this. I'll make it with other color. So we'll make this crosstalk something like this. So when we make this Z piece, the air is forced to go through this duct like this. And in this duct, we will do completely acoustic insulation, which will absorb noise. So that whatever the return air is there, all the noise is completely removed. Understood or not? So in
Yes.
return air for independent cabins and all, we'll go for something called as crosstalk dampers. Am I clear? Understood or not? We call it as
Yes.
crosstalk damper.
Crushed.
Okay, so these are your crosstalk dampers. Internal to the Z shape, you have, of course, it's not like we fabricate it as elsewhere. We can fabricate at site only. A plain duct sheet, they can make it, or using duct fabricator also, they'll fabricate it, and internally you will do acoustic insulation. Nitrile rubber open cell, or you will use glass wool glass wool with tissue paper. So these are the two types that we use. But whereas when you have higher noises like AHU room and all, in these cases, let's say this AHU has a lot of noise. Now I don't want any noise to be coming from the AHU to here or from here to inside, like studios or any of those cases. In those cases, we will install something called as sound attenuator. So this duct is basically, I mean, if you see the image, in a duct, you have multiple planes. When air pass through this particular one is a glass wool type of material, which will basically absorb the noise. Understood? So whatever air is returning, I mean, through this one also it will not escape. Even in supply also, you can install a attenuator if you're interested. Understand. It depends again on your noise requirements. Especially if you work on projects like recording studios, in those cases, it's mandatory for us to use these 80 meters. Clear? Or in offices like open spaces where you don't have false ceiling and you have a floor mounted AHU which can give you a lot of noise, then also you'll go for this kind of sound attenuators. So these two devices is used to regulate the noise level. Am I clear?
Yeah. Yes, sir.
Okay, so in the return or supply path, you can install this attenuator. So with this, we have completed all Dux accessories. So what all accessories we have learned are basically like, your duct fittings, like your flexible duct, volume control damper, fire damper. Fire damper, there are two types. One is with actuator, another one is with a fusible link. Then we had a discussion of the collar dampers, non-return dampers, Spygo dampers, pillbox. VAV, we didn't have a deep discussion, but probably in this week, like today's Tuesday, right? So Thursday, like that, we'll be going to air conditioning concepts. Once after the design is done, then we'll have a discussion about VAVs. Okay. Then we understood about the accessories like your sound attenuator and crosstalk dampers. So in these topics, you've got any queries or any other previous topics, whatever we have covered, or everything is clear?
Mm. Yes.
Yeah, perfect. So now we are going to have a discussion on something called as air terminals. Okay, we're going to have a discussion on air terminals. So first and foremost, or majority of the cases, we either use grills or diffusers. So you have different kind of diffusers that are available in the market. Sizing, don't worry. How do we size this? Using brochures, I'll teach you for each and every type whenever we work on a project. Okay. So during explanation of the project, then I'll explain you how to select these particular diffusers. Okay. So these are the general type of diffusers that we use. The first is square diffusers, where we use 90% of the diffuser usage. So we have something called as a square diffuser, where it will throw air from all the four directions. It will diffuse the air. The main advantage of this diffuser rather than grills is grills will directly hit the air over a person, but diffuser will diffuse the air through the ceiling. If you see the edges of this particular one, just a second. Why it did not happen? Huh. So if you see the edges of this one, so from the ceiling, when it is throwing air, let's say this is a ducting, okay? Let's say this is our ducting. I mean, from your main duct, you have a dropper using a collar or something. Then, if you see the section of this is not a straight holes. Instead, it will be like this. So because of this particular angles, what is going to happen is air is not going to come out. It will diffuse through this gap and it will come. So airflow will not directly hit on the surface. So in offices and all, we'll obviously prefer this because if it's a grill or anything, if you have used it, what will happen? People under it will always have headache because obviously cold air will be hitting them. But whereas when you use diffuser, the whole air is diffused to the ceiling and then it will come down. Because of that, you don't have any concentration of hair that is hitting anyone's head. Understood? So we go for this kind of diffusers, either square diffuser or round diffuser, depends on the aesthetics. Nowadays, you've got something called as a swirl diffusers, but the problem with this is discharge rate flow is very low. Only aesthetically, like if the architect insists, then you will use the swirl diffusers. Understood? I mean, aesthetically compared to this guy seems better. That's it. But if you wanted to discharge air for long distances, then you have to use jet diffusers. Okay, so these are your jet diffusers. If you go for double height areas or anywhere, you will see these kind of jet diffusers. Understood? It can throw even up to 20 meters like that. That's the capacity of this particular jet diffusers. Similarly, I've got something called as this is also kind of a jet diffuser, which we call it as eyeball diffusers. So this eyeball diffuser also we use it for long distances if you wanted to throw. Airports, those kind of projects where you have double height areas and you have to throw for longer distances, definitely you have to go for this kind of eyeball diffusers or jet diffusers. And you've got something else is not that there is something called as a drum louver that also we use it nowadays. I'll just add it over here. Just a second. There is something called as a drum louver. So these also we use it nowadays. These kind of diffusers also we use it, which we call it as drum louvers. So this drum louvers also you will basically use it. Just a second. So these are nothing but your drum louvers. Understood? So this drum louvers also we use it nowadays. I'll add it. I share you this PPT as well, don't worry. So we use this drum louvers as well nowadays. So this drum louvers is basically used for throwing air for longer distances. So these all are types of a kind of a jet diffusers only. Clear?
Mm.
Just a
Yes.
second. Just a second. Yeah. I hope I'm audible. Okay. Okay. So these are the types of diffusers that I'm audible, right?
Yeah, audible.
Okay. So whenever you have this particular one, uh, the screen is also visible.
Everything. Yes, sir.
Okay, perfect. So, so this jet diffuser, drum louvers, even your your diffuser, we use it for long distances. That means if you wanted to really throw 10 meters, 15 meters distances, then we go for this one. Remaining diffusers below 5 meters only you will use it. Understood? Okay, then you have something called a slot diffusers, architect's favorite diffuser. But for HVC designers, this is a nightmare. The reason is this particular one, these are like, because obviously when they go for this one, they'll ask for smaller which one. These are called a slot diffuser. You could see two slots over here.
Yeah.
Yeah, where the mouse is there, you could see two slots over the
Mm.
diffuser. So you
Yes.
have two slot diffuser, three slot diffuser, and each diffuser, each slot width also you have 15 mm, 25 mm, 20 mm like that. But architects, what will they do is they'll always try to choose like minimum one only. They'll say no, no, go only for two slot diffuser. Aesthetically, we want it clean. But the problem is for 1 meter of length, you will hardly be able to throw around 100 CFM or 125 CFM like that. Because of that, adjusting is kind of tough for us. So I wouldn't personally prefer this, but most of the projects, because of architects, we're forced to use this kind of diffusers, which are called as slot diffusers. Okay, so we use this something called as slot diffusers as well. Am I clear?
Mm.
So these slot diffusers, I'll teach you how to select the slot diffuser or how to size them. Don't worry. Each and every model will select during air distribution system. I'll be explaining it. Okay.
Mm.
Yeah. So fine. So this particular one is nothing but your slot diffusers that you will use it for where you have your, yeah, you were asking me something, sorry.
No.
Flow rate, you have a choice to choose even three slot, four slot diffusers also. But again, as I've told you, architects will mostly they'll ask only to use either two slot diffuser or something like that. Or even I've heard weird the request of even using single slot diffuser also. Okay. So these are the types of diffuser. This is your plague diffuser. Again, here, this is more aesthetically compared to your four-way. At the same time, each diffuser airflow rate is lesser. So hardly 200 or 250 CFM is what it can diffuse, not more than that for sure. Understood? But whereas your regular four-way diffuser or the circular diffuser can even allow it up to 500 CFM, 600 CFM as well. That's the advantage of this four-way. That's the reason 90% of the jobs we go for this four-way diffusers. Then coming to grills. So grills, we have something called as single deflection grill, double deflection grills. So what is this single deflection grill is this blade angle will only be single level. So that blade angle while fabricating itself, you have to tell them, is it 0 degrees or is it 30 degrees or 15 degrees like that. Max is 30 degrees that you have it. You don't have more than 30 degrees. So generally you consider any of the angle you have to propose. The second one is double deflection grill, where this particular, if you can see, there are two layers. So air can, it's something like your car vent. So it can move left or right, or it can go above and above and below also, which are movable sometimes. So these are your double deflection grills. That means you are giving four directions in one grill, but you have to push it with an angle. But aesthetically, that will really look awkward. And this type of fitting is possible only for smaller grills. If the length is very large, then you can't have again this double deflection grills. Only you can have double angle. That means bottom some vanes and above some vanes you can have it. Understood? Hello?
Yeah. Yes.
Yeah, able to follow or you want me to explain once again?
No. No.
Huh?
Okay.
Yeah?
Yes.
Okay. Then coming to the next one that we have is something called as perforated grill. So what is perforated grill is the grill is actually having holes in it. That's all, nothing else. So in clean room kind of projects where we have these HEPA filters. So what will we do is basically filter will be backside of this. So that will already reduce the velocity. So that should directly come into your room space. In those cases, we go for this perforated grills. Especially in clean room projects, we use this. Then we have something called as floor grills. So where you have to supply or take return from the flooring, then we go for this floor grills. Okay. So in few cases, especially like clean room projects, where you have to maintain absolute cleanliness. For example, I'll just give an example. Let's say you're working on a project like let's say you're working on a fab. Fab is basically an electronics manufacturing company. Let's say it is trying to assemble a display. Now, between two, so display means it has a layer of LCD over which glass is present. Now, while fabricating it, let's say small particle have entered into it. Do you think the whole display will go for a toss? Because it will kill the experience and probably that will act like a resistor. Because every chip is in micro level when you're when you try to scale, even a small particle will change the entire circuit design, right? So your air clarity is really important. In those cases, you have something called as uniflow, laminar flow that you have to maintain. That means you will basically discharge it from the slab and you will take the return from the ceiling. So air will not get distributed at all. 100% whatever air is coming, it is only passed through HEPA filter and it is coming. In those cases, we go for these return grills. Understood or not? Or in application like server rooms. In server rooms, let's say, I'll just give an example over here again. Let's say you've got a server room. It's not a clean room though. Server room is not much into a clean room technology. Let's say this is your server room. You have server racks over here and one more rack over here. One more server rack, you have kept it over here or over here. It could be anywhere. So now in these cases, basically, whenever you have servers, we go for something called as false flooring. The reason why we do it is you have a lot of network cables, right? Whenever you have a server, don't you think each server rack will have like a lot of network cables or not? Cat6 cables.
Yeah.
You might have seen it in
Mm,
your company's server room. Ever
mm,
observed?
yeah. Yeah.
The case when you have a lot of cables, architecturally, what do we do is, let's say this is your civil structure. You have one ceiling like this, one floor like this. Over this, you have your rack, so that all the cables and all will go underneath this particular one. And directly it gets connected, and from here it will come out and then it gets terminated to your server. So a bunch of cables can enter like this. Understood? So that it is not when you have multiple server racks, the people can easily walk around this particular one and access the service. So in those cases also we go for floor grills. So what do we do is, if you see a section, let's say this is your section, these are your server racks, let's say. What do we do is we use the other hardware called as the PACs, or precision control package air conditioners. Mostly we use it so that we can control proper RH as well. This is your PAC. So this PAC will have coil. Okay, so what will happen is this guy will throw air beneath the, I mean, you'll have a airflow rate in this direction. The line with 500, 200. You have airflow direction in this direction. So suction will be from the top and the discharge will be from the bottom. So you'll have multiple coils and all. So we can ask whatever model it is anyway in PAC. So let's say I've ordered bottom discharge and top suction model of PAC. What will happen? We'll pump the cold. We don't use any ducting. Instead, we will just insulate the wall and all so that heat won't escape. So from here, you'll just pump cold air beneath the flooring where cables are also there. No problem. So basically, you pump this cold air into this particular one, and servers, each individual server will have its own fan anyway. Each server will have its own fan, like your PC has got a fan or not.
Yeah. That's good.
Similarly, it has got a similar fan in this direction. So generally what will happen is the direction of the air that's absorbed by these are something like this, let's say. That will be told to us by the manufacturer. Let's say, air is going into every server rack like this. Clear? So in this case, what will happen? The air is going like this, and then it will have electronic PCB, and from here the air will be coming out again. Hot air will be coming out. So what will we do is basically, so let's say this is your air that's entering, and again this is your air that's leaving after heat exchanging. Okay, so what do we do here is basically we will place something called as floor grills at these locations. So just in front of its suction, wherever it is there, you provide something called as a floor grills. Understood? So now, of course, it can have a damper as well. It'll have a damper as well. So when this particular air is flowing, the whole air, so this entire chamber, don't you think it will be filled with your air or not? The whole chamber will be filled with your cold air? Yes or no? This whole
Yeah.
chamber will be filled with cold air, and wherever you have punctures in it, the air will be diffusing through this particular ones. You agree?
Yeah.
Through this floor grills, the air will be distributing around. So in these applications also, so and retainer, what do we do? Instead of doing ducting or anything, I'll just provide like one more ducting. We'll just provide a kind of a duct over here from the AHU. We'll just connect a duct something like this. Let's say just this is your false ceiling, let's say. So we will leave the false ceiling and we will use retainer diffusers on the top at this point. So this will be your retainer diffuser. So what will happen? The suction will be from this direction and discharge is at this bottom. So all the hot air, don't you think it will reach through the ceiling and it will come back to your AHU or not?
Mm-hmm.
Because all the air, automatically what will happen? This air will reach above, obviously. This air will reach above this particular diffuser. From this diffuser, it will come back to your particular AHU. So like this, you will recirculate. In those cases, you have to go for your ceiling normal four-way diffuser grills. Generally, we use it. Discharge volume is higher. And bottom, you'll go for floor grills. So you'll use your floor grills at the bottom and you'll go for normal grills on your ceiling level. Understood or not? So this is how we basically
Mm-hmm.
design it for your server rooms or any such applications. Understood?
Yeah.
So this is your like floor grill. This is your linear grill. These type of grills, smaller sections, you call it as patch grills. And the next one that we have is something called as luvers. You have multiple types of luvers. So one, the general luvers that you use is basically a pressure lever or exhaust air lever. So these are used externally when you wanted to suck some amount of fresh air. If you directly provide grill, don't you think rainwater or anything can enter through this? If you use normal grill? But whereas in this
Mm-hmm.
particular one, the section is made in such a way, so if you see a section, it will be something like this. The whole section is made something like this. I mean, the blades are actually aligned like this. Just a sec, you have it in this fashion. So when you have it in this fashion, let's say this is your internal wall and this is your external surface. Right side is your external. So when you have this external, do you think any rain or anything can enter through this particular one? Just like this is the total section, let's say.
No. Mm-hmm.
Yeah. So this is total section you have it. So when you have it, automatically rainwater, if something enters also through this angle, again it will fall back. You agree? So inherently we design it. Only thing is the sealing of this particular corner, it needs to be done properly. If that's not done, no one can help you. Understood? So basically, this location you have this particular wall surface, whatever is it, that needs to be done. So here, if you have a civil wall or at this location, that needs to be sealed properly. That should be done by civil team. Understood or not? Because I've seen a lot of places where after this you'll find a leakages that because of the gap at this location. Understood? So when you install a louver, you should make sure that this particular one is sealed properly. Understood? You have to do grouting or anything with GPT or any other chemical. Clear?
Mm-hmm.
So anyway, so this is nothing but your this is nothing but your louvers. So for fresh air and exhaust also, you'll basically use this particular louvers. And nowadays you get it along with the mosquito, like in a kind of a GA mesh, so that any small insects cannot enter into this particular one. Yeah. So this is nothing but your louvers. So these are the total air terminals that we use in your projects. Selection of this one, as I told you, I'll be explaining you once we go into design. Clear? Got
Okay.
any queries in this? No.
No, no, no.
Yeah. So now coming to the next one is about ducting. Okay. So when we consider the ducts, this is again the theory part. That's it. So this is basically used for fabricators. So when you have ducting, you have different kind of joints. So the following joints are there. One is basically slip-in joint or weld joint, we call it as. So basically it's crimped and then we do it. Interlocked. This is a generic one that we use it. Okay. Interlock joint that we call it as when we don't want any flanges. But this again, along the length of this kind of joint, the seaming is okay. But when you consider a normal one, we don't use this interlock joint. We go for this flanged and gasket joint. We generally go for this flanged and gasket joint. So that air will not leak at all. Understood? So basically between two ducts, we have this flange and then we basically do the joining. So 99% of the cases, TDF flanges, we call it as where the between two ducts, you basically, I'll just show you a better image. Just a second. Duct TDF joint. So you can see this particular image. Yeah. So basically what do we do is we apply a gasket over this. One more duct of a similar one, it will come. And through these holes, you will basically join using your normal nuts and bolts. Understood. So using that, you can join your ducting. Am I clear? I mean, different piece of ducts will be joined using that. So if you see a duct, I mean, it is done by duct manufacturer anyway. Side will be this will be seaming, whereas this particular one is your TDS joint. So this is again additionally this is procured and then you add it at this corners. You will basically add it. I mean, you get it along with the fabricator at the corner, all the four corners, whatever is there. I'll just show you image. You can see a corner over here with a hole. Just show this particular one. Slide. Yeah. You could see some kind of four, you can find some kind of a small hole in this. Yes or no? Okay, so are you able to see?
Yes, 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 yes.
Okay. So this particular one is independently fabricated and we join it by the, I mean, at the factory itself, they do it. Or sometimes this will be loose, means sometimes once it comes to the site, then also you can join. So basically what will happen, this duct will be, I mean, provided, I mean, this is manufactured like this actually. If you see your ducting, basically, what do they do it is a normal sheet. Generally, each roll you will get around 1.2 meters. So that roll is basically bent in this fashion. So each duct length will not be greater than 1.2 meters. 1.5 you get it, but again, because of this TDF flanges on the other side, you don't get each duct more than 1.2 meters. So between 1.2 meters, you basically join the duct something like this. I mean, every 1.2 meter duct length, you will basically join using this text. Understood or not? And you will connect it. So you apply a gasket over it, and then you both the sides you will basically add multiple bolts. So this is 99% of your factory fabricated ones. You will get this one. But in few locations, what will happen? There's always a challenge of height that's available at site, like bottom of the beam and the bottom, if the bottom of the beam and bottom of the fall ceiling is less, then if you wanted to use this kind of TDF joints or bottom of the slab also, if you have less, what will happen? These also will, because these height will be 32 mm. 32 mm on the other side is kind of waste for us. You agree? So in those cases, you specially order these, this interlocker type of joints that you get it at site. I mean, at site you have to do certain fabrication again. I mean, you don't have other choice. I mean, you have to bend it and you have to hit it with a hammer inside the site. Understood? So these kind of thing also we can use it. And this double slip in and all, you have some leakages, so we don't use it again. It's rarely we'll use it. You use it in locations where additional component needs to be added. That's it. Else we generally don't use it. Weld we use it only for MS ducting. That is also especially very high temperature air or anything. If you have to remove, only then you'll go for this welding. For GS duct, GSS sheet, you don't use it at all. Only for MS duct you'll use your welding. Understood? So generally we use this flanged and gasketed model. Interlocked model is these two elements is what we use it to a major extent. Clear? So these are the type of duct joints that we regularly use. And coming to the next one that we have is duct supports. How do we support a duct? They're threaded using anchor fasteners, obviously, and then you will use L angles as well. If your duct, please make a note, this is quite important. If your duct width is, someone entered now or what? Yeah. Hi, Mohammed. Woke up late, Mohammed? Please try to join early tomorrow onwards. Anyway, so when you consider your duct supports, basically, so if your duct width is lesser, let's say the duct width is somewhere around 800, 700, like that, in those cases, you'll go for the slotted joints, slotted channels. So that also we use it up to 1200, we'll go for this a slotted joint. About 1200, if you have a duct, we'll go for this L angle. Understood? So slotted angle, we'll use it up to 1200 mm width. About 1200 mm width, we'll always go for this L angle. Am I clear? 1200 to 1500 depends again on consultants, but yeah, I would prefer to about 1200. We'll go for this L angles. Lesser than that, we can go for slotted channels. Clear?
Yes.
Pull your weight of the duct. So how does it work is simple. If you see it, so first what you do is you basically drill the slab and then you insert inside. You insert this entire thing internally inside and then you rotate it. You screw it. So once it's screw, it expands inside your slab. So I'll just explain you over here. How does this work is, let's say this is your slab. So you have your rivet. First, what you do is you take this particular rivet and then you first drill the slab and then you insert into this. And once you insert into this, what will happen is at this location, what you do is you basically have a threaded rod here. So this particular thing will be a threaded rod. You'll have your threaded rod here. Okay. So once you have
The
this threaded rod,
anchoring.
yeah, anchoring. Anchoring is what we do it anyway.
Mm.
So when you anchor it, what will happen? This when you rotate it, you're forcing this wedged joint to enter into this gap. So what will happen because of so you have a wedged joint here, right? Just a sec. So you have a kind of a crack in this particular one, a small gap you have it. So in this case, what do? You basically try to push a wedged joint. So when you push the wedged joint, you can see a wedged joint over here, this joint where the mouse is there. So when you try to push it, that will expand. So when it expands, it will hold concrete properly. So what will happen? It will slightly deform like this. So when it deforms, don't you think it will be able to hold it properly? Because this is entirely is concrete, right? So when you expand it, automatically it holds that. So when it holds it, you will be able to, it will be able to hold the surface properly. Understood? So this is nothing but your anchor fastener, we call it as. So to the anchor fastener, you'll have your threaded rod. You will have your threaded rod. So these threaded rod diameter, again, I'll teach you using the design stage, don't worry. According to your duct width or according to your AHU weights, you have to choose the diameter of your thread rod. Generally, we go for 8 mm. If the duct size is bigger, then we go for 10 mm. If the duct size is very big or MS duct, if you use or AHU and all means, then you go for even 12 mm or 15 mm thick rods. Understood? So these are your threaded rods that we use it. So these are your threaded rods, and then you'll go for the slotted channel like this. And one more threaded rod will be on the other side. Here you will basically place your ducting. Understood? Let's say this particular one is your ducting system. Understood? So like this will, so this will be slotted channel. If your duct width is like lesser than or equal to 1200, if it is more than that, you go for L angle. Understood or not? Am I clear? Yes,
Yeah,
please
yeah.
respond.
Mm. Yes, yes.
Okay, check it. Then coming to the next one is this is your duct hanger that we use it. Especially this is not for like rectangle for small diameter ducts or anything. If you use this is also called as universal clamp as well. So for pipes or even for smaller circular ducts or even for flexible ducts, especially we use this duct hangers or universal. This we call it as universal hanger as well. For pipes, for a lot of things, we'll use this anchor. So this is simply you have a piece like this, and then you have a common one, and you have a common hole. So you puncture through this, and then I mean you will have a puncture provided to you by the manufacturer. So from there, you take a thread rod directly to the top. You have a nut at the bottom. Understood? So here for flexible ducts and all, you will go for this kind of universal joint, universal hanger or universal support. Also, we call it as. Understood? So these are the type of duct. Suppose we use it. Clear? Now, the next one that we'll have a discussion is basically our insulations. So these are the materials that we use for insulation. One is your thermal insulation. I mean, olden days we used to use this rock wool or glass wool. The yellow one is glass wool and the brown one is your rock wool. So glass wool or rock wool we use it for insulation. The olden days we used to use, but nowadays we go for this nitrile rubber, which is easy for us to stick it to the surfaces. So we use something called as this thermal insulation, where we just apply your SR gums. I mean, Fevicol or Pidilite, you have got multiple brands who basically provides you the gums. So that particular gum, you basically stick it over the rack. You wait for 2 minutes to dry, and then you stick it over the surface. As simple as this. Okay, so this is simple to work. So we use nowadays this one. So in nitrile rubber, you have got two types. One is closed cell, and other is open cell. You could see the difference between the top and bottom one. Hello.
Yes.
So the top one, don't you think it's smooth? So this will not absorb sound. It is only used for thermal insulation, and it is comparatively cheaper. So this we use it for nitrile rubber. This particular one we use it for thermal insulation. That means if you don't want any heat transfer. Whereas acoustic insulation, you use it to absorb the noise level. So at the start of the AHU or anything, we go for this acoustic insulation. Clear. So during design stage, I'll explain you how much lengths you have to use your thermal insulation, acoustic insulation. Don't worry. But whereas in olden days we used to use this glass wool or rock wool even for thermal and acoustic insulations. But nowadays we don't use that. We use it still for AHU walls if you want to insulate. In those cases only we'll go for this rock wool or glass wool so that noise from the AHU is absorbed and it's not coming out through the wall structure. Okay. So we use this glass wool or rock wool for civil structure insulations, whereas for our ducting, we go for this nitrile rubber. Nitrile rubber closed cell is used for thermal insulation. Open cell, you use it for acoustic insulation, where noise needs to be absorbed. Clear? Now, coming to the next one is basically your ducting design. So you have something called as velocity reduction method, constant friction method, and static regain method. So velocity reduction method means what we do is we reduce the velocity slightly as the air flows further. Okay. I'll teach you this design concept, so don't worry. We will take a small example and then we will proceed further on these different types of duct designing. It's a part of a distribution. From tomorrow, we are going entering into design part of the project. So that time we'll have a detailed discussion on how to work on it. But I just wanted to brief you upon this type of duct designing. All the three types I'll be explaining you. First is velocity reduction method. So in velocity reduction method, let's say your main duct, I'll just give an example. Let's say you've got a main duct which is 2000, sorry, polyline with two subscript. One, it's not happening. Polyline of 2000, 2000. So you have got your main duct which is like this. And then you have used some collars. Obviously, you have used some collars. And then remaining air, you have to push it further. 2000 to 1000 you have designed again. 1000 you have done. And from here, your duct is something like this. So here you have basically thrown some amount of air. So let's say some amount of air, you have thrown it here. You have discharged it using collars over here. Here, remaining air, you are throwing it. Then what will happen? At this location, at the bigger size, your velocity will be higher. As the air will be traveling further, you will reduce the velocities. The reason why we do it is for lesser air volume, if you keep same velocity, your friction factor will increase because you will reduce your duct size also, right? So for that reason, you will use something called as velocity reduction method, where from the start to the end, slowly you will reduce the velocity. Understood or not? And maximum velocity we try to maintain is around 1500 fpm, feet per minute. So these things you will understand while I design it for our project. We have already worked on one heat load calculation with VRF system, right? But entire central workstation, don't you think I'm supposed to do air distribution? So when I do this air distribution, then I'll explain you both the methods. So one duct I'll use using velocity reduction method. Second duct I'll use using your friction method. Is it okay? The next one is friction method. So constant friction method means you will assume certain friction factor. It should be lesser than or equal to 0.1 feet per 100 feet of ducting. Sorry, 0.1 inch for every 100 feet of ducting. So considering that as your friction factor, you will basically design the entire ducting. Understood? So instead of changing velocities, you will keep your constant friction as constant, and then you will design the ducting. So that particular method is nothing but your constant friction method. The last method that's rarely used but very efficient is basically static regain method. So the static regain method is you design your ducting in such a way that resistance offered by the last air terminal till the start is same, so that you need not really worry about air balancing. I'll just give an example. Okay, let's say this is your duct. One duct is going like this, one duct is going like this in this direction. This duct have come further, and one have been done like this, one throw is like this. So let's say these are the air terminals, 1, 2, 3. So these are the three locations where I'm throwing air. I'm just giving an example. Okay. Now, technically, if you have a AHU over here, let's say, I'm just giving the same. I'll write it as 300 or something. So this is your first one. This is your second one. And this is your third terminal. Technically, if you ask me, where do you think more air should come if you don't do any air balancing? Out of 1, 2, 3, we will have more airflow rate.
Good.
1. Why? Why at 1?
No disturbance is there. In 2 and 3, one equal, it will distribute equally. It can distribute.
Might not be, because if this length, if third length is lesser than 2, let's okay. To make it more convincing, let's say I'll make it like this. Okay. Now tell me.
Air will
How do
go
we
to
do it?
heat to one place.
Huh? I didn't get you, sir. Yeah. So, no, which will have more airflow rate out of 1, 2, 3? Yes, I asked you a question.
One
Why is a question?
nearer to
Yeah, the reason is simple. As it's near in the sense, like any fluid will flow in least resistance path. You agree?
yeah.
That means whichever is easier or where I'll have lesser pressure losses in that particular area, I have more volume. And I'll get less volume in location where I have more pressure losses. You agree? So now design stage itself will remove it. How do we do is, let's say, I'll just give an example. A static regain method, because anyway we are not doing it. That's the reason I'll explain you the method at this point. So let's say here the friction factor is, I'm just giving an example. Let's say the friction factor I've designed this entire thing is somewhere 0.1 inch per 100, like, per feet. I mean, I'm just giving an example. That's it. Don't take it to the core. Let's say this is 1 feet example. 0.1 inch per 1 feet length. Generally, it should be for 100 feet, but for a ease of calculation, we have done it like this. Okay. But now, let's say this particular length of the duct, I'll just give some random lengths. Don't worry. Dimensions, modify. Primary units, let's say, is text is 500. Simple and arrow is also 500. Let's say. Plus up. Now, let's say this length is, I'm just giving an example over here. Let's say this length is somewhere around some 20 feet. This length is 20 feet. This length is somewhere around some 10 feet. This length of the duct is 10 feet. And let's say this length of the duct is also, this length of the length is 15 feet. Okay. And this duct length is, let's say, is how much? 8 feet. And this duct length is 6 feet. Okay, and here this duct length, from here to here, the duct length is hardly any, say 4 feet or something, 4 feet. And this also is 4 feet. I'll just teach you the method of for the static regain. 4 feet. And let's say here, this guy is, let's say 7 feet. Understood? So now, how do we design? Let's say first I've designed this duct entirely up, because 2 is definitely the longest one, right? If you consider the numbers. Just a sec. I'll change the texture to 1000, I guess. That will be better. Okay. So now if you could see the numbers, basically, what is happening? So this duct length is up to terminal 2. Don't you think the length is more? 20 feet plus 10 feet plus 15 feet? Yes or no? But whereas at this terminal, it's only 20 plus 8 plus 6. Here, it's only 4 plus 4 plus 7 to air terminal 1. Yes or no? Now, let's say I've designed it entirely for terminal 2. I'll just use an Excel sheet for my ease of calculations. Home, August 2025. But yeah, some calculation sheet. Yeah. Okay. Now, let's say I've got a particular one. Tell me if it's not visible to you. Okay. So, so first I wanted to write the distance. Distance to one. Alt AC. Yeah. So this is terminal number, and duct length. Duct length. Okay. Now this terminal number, if we take it, terminal number one, if we take it, what is the duct length? We got it 4 plus 4 plus 7. You agree? Able to follow or not, guys?
Yes.
Yes, sir.
Okay. Terminal 2 is 20 plus 10 plus 15. Terminal 3 is equal to 20 plus 8 plus 6. So these are the total lengths that we have. Now, the entire, for example, I have done entire up to 2 terminal. I've designed the entire duct length with 0.1 feet per 100 feet. So let's say this part of the duct, I've designed it with 0.1 feet per 100, 0.1 inch per 100 feet. So here the friction factor, I'll take it as 0.1 inch per 1 feet here, not 100 feet in this case, as for my ease of math, I'm doing it, that's it. So here it is 0.1 inch per 100 feet, right? So for equation 2, I've designed only this particular duct, in this particular duct. So you will do duct sizing in such a way that your friction factor is 0.1 inch per 1 feet for this entire length, or 100 feet only. Stick, I'll not come. I mean, later on, you will take that as granted. That's the reason. I wanted to change it to 100 feet. 0.1 inch per 100 feet of ducting. I've designed it for 0.1 inch per 100 feet of ducting. So if you take it like this, what is the total pressure friction loss? I'll have 0.1 inch is equal to, so this is your friction factor, is equal to 45 into 0.1, sorry, is equal to 45 feet into 0.1 divided by 100. So it is 0.045 inches. You agree? Yes or no?
Yes.
So you will design this ducting with 0.045 inches of volume. That means the total resistance offered by the ducting, I mean, you remove the bench and all for now. So from this point to this point is 0.045. You agree? Understood this calculation or not? Up to terminal 2, the loss that will be incurred is, or the resistance due to friction will be 0.1 inch per 100 feet is what I've considered. But the total duct length is not 100 feet, it's only 45 feet. So total loss is only 0.45. You agree? Yes or no?
Yeah.
Okay. Now what we have to do, we have to design it for 0.3. So if you, sorry, third terminal. So if you design it for third terminal, basically, you already know that this is 0.1 you have already designed. Now you can't change it. You agree? So for third one, I'm just drawing it. For third terminal, I'm just drawing it. Okay. So duct length is 34 feet. So out of 34 feet, if you see 20 feet, what is the duct friction that we got is 0.1. You agree? Because out of this, Shrivali, Satish, go ahead. Okay. So out of this entire thing, if you see, out of this feet, this 20 feet friction factor is 0.1. You agree? Because already we have decided this entire main duct is 0.1. Yes or no?
Yes.
So the loss already incurred is 0.02. Right. Now what you should do, the remaining two ducts, we have to design in such a way that the friction loss is equal to 0.045. That means the total loss is how much now? Here is equal to this minus this 0.025. That means the total, the remaining duct you should design it with 0.025 should be the equivalent value. What is the remaining length that's available? 8 plus 6. You agree? 8 plus 6 feet. 14 feet is pending. Now I have to design it with this, with such a friction factor that I'll have this value. That means this is equal to, this should be the total loss, right? So friction factor is equal to, what did we do? Into, so for this, the formula is divided by 100, B6 into C6 by 100. Now we require C6. So C6 is equal to this value into 100 divided by 14. You agree? So I should design it with 0.178 friction factor. Understand? So instead of 0.1 inch, I have to design it with 0.1778 inches. Clear? So this entire duct length, we have to, instead of 0.1, we have to design it with 0.78. So that, so if we consider this, the total value will be again equal to these two. Sorry. Is equal to sum of these two elements. I'll take it. So it is 0.45. So what is happening? The friction factor from here to here is same or not? So up to 0.3 also it is 0.045 only I maintained. Up to 2 also from the start I maintained 0.045. Now coming to the third one. First one. So if you take your first one, I'll do it. So in first one, if you do it, you already know certain duct length because this 4 feet, you have already designed it with, your 4 feet, you have already designed it with 0.1. Because this main duct, you have already designed it while designing it for 0.2. So this is how much will it be? 0.1 means this is the 0.1 friction factor. So automatically the loss is only this one. 0.004 only you had. But remaining duct length is how much? 7 plus 4 is how much? Is equal to 7 plus 4. That's 11 feet only spending. Out in 11 feet, you have to get remaining value. So is equal to, because I have to get 0.45 alva. 0.045 no matter what. So is equal to this value minus this, I have to do it. So when you do it, this will be 0.04. So out of within 11 feet, I have to get 0.041. So my friction factor should be something like this. 0.372 friction factor I should. 0.372 should be 372 should be your friction factor. So if you observe over here, this entire design we have done it with 0.1, but this branch we designed with 0.178. But with this branch, we have made it with 0.372 inches. So now don't you think everywhere the air will flow equally because the total resistance offered is same? Though this length is shorter, I have squeezed the duct in such a way that my friction factor is 0.372 inches I lose for every 100 feet. But whereas here it lose only 0.1 feet. Now, don't you think at all the locations the friction factor that I get is 0.45 only or not? Either it's path from AHU to path 1, path 2 or path 3. My total friction factor is same. So your resistance offered is same. Now, do you think at least your airflow volume will be like distributed equally?
Yeah.
Yes or no?
Yeah.
Okay. So when we do this particular activity, Shrivali, curry or dekko.
ఆనియన్ టొమాటో వేసి చేసేదా టొమాటో ఎక్కువ వచ్చేదా
Just a second. I'll. Okay. So this is clear. Hello. Yeah. So now when we design it like this, we will make sure that airflow rate is constant through the system. So that means basically from the AHU to 1 to 3, you have maintained same friction, which is 0.45, which will definitely result in equivalent airflow now or not. So now don't you think whatever air I throw, if I throw 500 CFM, it will divide it by 3 equally. If I throw 3000 also, 1000 CFM will equally flow through each and every terminal. You agree?
Yes.
Yeah.
So this doesn't require much. VCDs and all is not required. No air balancing is also required. Understood? But
Yeah.
even for bloody the small duct, we are really worrying about the diesel calculation. Now imagine if we got like 30 terminals or 40 terminals. Design itself will take 3-4 days. You agree?
Yeah.
So to remove that complications, we don't use it practically at all. We use constant friction method or velocity reduction method. And instead of all these headaches, we'll go for volume control dampers where we apply manual resistance to make sure that the airflow rate is required. So we'll do air balancing once after the job execution. Understood or not? So when you do static regain method, you need not do any air balancing or anything. But calculation will be a headache. But whereas instead of that, we go practically, we always go for normal, method where your velocity reduction method or constant friction method. So using these elements will basically work on your design. The static design method concept is this, where you basically make sure your friction factor is maintained in such a way that for every air terminal, the loss is constant. Am I clear? Hello.
Yeah. Yeah.
But anyway, that is a short note on static regain method. But anyway, we are not going to further discuss about this. So with this, we're completing static regain. We'll use velocity reduction constant in further lectures. I'll be explaining you. Yeah. So these are concepts of velocity reduction method and all. I'll be explaining you later. And this is a constant friction method. Static regain method, we already had a discussion today. Right. So we have something called as velocity reduction method, and we have got something called as constant friction method. In velocity reduction method, you make sure that the duct velocity is between 1200 to 1500, but at the same time, your friction factor should not be more than 0.1 inch per 100 feet. Okay. Tomorrow, I'll take an example of a ducting and then I'll teach you what is called as main duct, what is your branch duct, what is your collar duct, and what is your dropper. Okay. Then I'll explain you about this velocity reduction method and constant friction method. First, I'll explain these two methods clearly, and then we will further discuss on how to design it for a project. Is it fine?
Okay, sir.
So this is a short note on air distribution system, yesterday's and today's lecture combined. Tomorrow we will be working on the design aspects of this air distribution theory. Clear?
Okay.
Okay, so still the following topic. So after this air distribution, then we'll go into water distribution system where I'll be teaching you about pipe design and pump selection. So after this air distribution, I'll introduce one more topic called as fan selection, where I'll teach you how to select a particular fan. Yeah, because for that you have to understand what are the losses that's incurred. That's the reason we can't take up that first. So first we'll understand the duct design, then we will select a fan for that. Yeah.
Okay.
Are we going fast or the space is fine for you guys?
It's fine, sir.
Okay. Fine then. So we'll continue again from tomorrow. So this is a short note on static regain method. It's okay. I'm not saving this.
Okay.
Take a snap and I'll share it in the WhatsApp group. That's okay. That should be fine. That is how you basically do your static. It is just for explanation of that. So first from the tail end you do it. That means from the longest path you take it to the shortest path in this case. Yeah. Okay. So with that we have completed today's this thing. Tomorrow again will be continued. Okay.
Okay.
Fine. Mohammed, try to join a bit early, buddy.
Okay.
And anyway, yesterday's video was uploaded in same YouTube itself. You can just listen it or download it. Whatever you want. Okay, fine. This also tomorrow again I'll upload it.